Now today we are going to learn about the basics of the complex numbers. In previous videos I discussed about the geometry of complex numbers, and I want to give you the basics of complex numbers in this video now. So before going to details about the complex numbers, you should know about the natural numbers, integers, real numbers. So all these numbers you should know. After that, we will learn the complex numbers. Now you see, first I want to solve some equations. Like, for example, if I take a simple equation, a simple linear equation, x plus 3 equals to 0. Okay. Now, if you want to solve this equation, very simple. That is x equals to minus 3. X equals to minus 3. So that is by adding minus 3 on both sides, we can get this. So what is minus 3? Minus 3 is an integer. So minus 3 belongs to z, is an integer. So what we say, x plus 3 is equal to 0 has a solution in the set of integers. Now if I go further, 2x minus 1 equals to 0, from which we can get the value of x is 1 by 2. So what is 1 by 2? It is not an integer. There is no solution of 2x minus 1 equals to 0 in the set of integers, because of we got x value 1 upon 2. Now here 1 upon 2 is a rational number. So therefore we can conclude that 2x minus 1 equals to 0 has a solution in the set of all rational numbers. Now if I see one more example, now you consider this equation x square minus 2 equals to 0, which is a quadratic equation obviously. So x square minus 2 equals to 0. If I solve by using the factorization method, I can write this as x minus root 2 into x plus root 2 equals to 0. Of course, a basic simple identity, a square minus b square is equal to a minus b into a plus b. Now, from this, I can get the values of x are root 2 and the one more is minus root 2. Here root 2 and minus root 2, they are not integers, as well as they are not rational numbers, they are not natural numbers, but these particular numbers are called what? Irrational numbers. So if I speak about the equation x square minus 2 is equal to 0, now x square minus 2 is equal to 0 has no solution in the set of integers, has no solution in the set of real numbers, but here we have a solution which are neither integer or nor rational numbers. These are irrationals. So we say, or we say irrational numbers are also real numbers. I can say the equation x square minus 2 is equal to 0 has solution in the set of real numbers. Now the next I want to solve this equation x square plus 1 equals to 0. Now suppose we know up to the set of all real numbers only, then there will be a problem. So how to solve x square plus 1 equals to 0? So we know a property in the set of real numbers that if you take any real number, the square of any real number is always non-negative. The square of any real number is always non-negative. Maybe it will become 0, maybe it will become always positive. So for any a, if I say belongs to R, a square is always greater than or equal to 0. So if square of a real number is always greater than or equal to 0, if I add 1 to that value, what happens? It will become more than 1 or equals to 1. But what I wrote here, x square plus 1 equals to 0. So for x square plus 1 equals to 0, there is no real solution. Means we cannot find out a value which is in the set of real numbers which satisfies x square plus 1 equals to 0. So I mean to say that there is no solution for x square plus 1 is equal to 0 in the set of real numbers. So what we will do now? Now here we define something like called I. Say I equals to root of minus 1. Actually, why we use I? There is a name for I. We say iota. It's called iota. So root of minus 1, if I denote by I, what happens in next? I square will become minus 1. So I square equals to minus 1. So if I consider x value as I, what happens? That x square will become minus 1 plus 1 will become 0. So this is the solution of x square plus 1 equals to 0. It's called imaginary number. Now we define iota equals to root of minus 1. Now here we are going to see about the powers of I. Now, how to calculate the highest powers of I and what are the properties connected with I that we are going to learn now. So now I equals to root of minus 1, therefore we know that I square equals to minus 1. Now then what is I cube? I cube equals to I square into I. Now I square is equals to minus 1 into I. So minus 1 into I is minus n. So what is that? I cube equals to minus I. Now, what is the value of I power 4? What is I power 4? I power 4 equals to I square whole square. Now, but we know I square equals to minus 1. So, minus 1 whole square, that equals to plus 1. Now, what we have? I power 4 equals to 1. So these are the basic powers of I. We must remember I square equals to minus 1, I cube is equals to minus I, and I power 4 equals to 1. Now you see what happens whenever you want to calculate I power 5. Now I power 5 equals to I power 4 into I. But I power 4 equals to 1, therefore 1 into I, that equals to I. So means I power 5 is equals to I power 1. Then what is I power 6? I power 6 equals to I power 4 into I square. I power 4 is equals to 1. Therefore, this will become again I square. Now, once you observe, whenever you take I power 5, by removing 4, because of I power 4 is going to be 1, then by removing 4, subtracting 4 from 5, we get I power 1. Now I power 6. Because of I power 4 is 1, directly you can remove 4 from 6, that gives you I power 2. Now I power 7 is what? Now we are not going to use this technique. Just I will remove 4 from this, so I will get I power 3. So I power 8 is what? I power 8 is I power 8 is equal to I power 4, 1 more I power 4, that is 1. So whenever you want to calculate the highest power of I, whenever a larger number is given to the power of I, for example, I to the power of 315. Now I want to calculate I to the power of 315. Because of every time this I power 4 gives 1. So how many I power 4s are there in this? So therefore you have to remove 4 every time. How many 4s are there in 315? Means you have to remove 4 multiples from the 315. So how many 4 multiples are there? You have to calculate now. So if you take 4 multiples, where this 315 will come? So just by removing 4. So this you can write I to the power of 4 to the power of something here you will get. What is that? 7, 8. So what is 78 into 4? You see this. 4 8s are 32, 3, 7 4s are 28 plus 3, that is 312. We are getting 312. So what I wrote here, I power 4 to the power of 78, 312 is already completed. The remaining power is 3. So this is 1. So directly we can get I to the power of 3. So what is I to the power of 3 again here? I cube equals to minus I. Therefore I cube equals to minus I. So this is the way of calculating the larger power of y. Whenever the number is very big, just you remove the 4 multiples from that number. The remaining power will appear as a power of I, and that gives I square or I cube or I power 4 or I power 1. So this is the way of finding I to the power of a larger number. So for example, you want to calculate I to the power of 2003 or 2, I to the power of 2002. So this is nothing but I to the power of 2 only, because of 2000 is a multiple of 4. So by removing the multiples of 4, the remaining number will be 2. So I square value is minus 1. Cut it down. So therefore I to the power of 4 multiples plus 1 gives I to the power of 1, that equals to I to the power of 4m plus 2 equals to I to the power of 4m. So therefore that is I to the power of 4 to the power of m. Therefore that will become 1. So the result will be I square, that equals to minus 1. I to the power of 4m plus 3, that is equals to I cube. That is equals to minus I to the power of 4m plus 4. Actually it's nothing but I. If you take 4 common, it will become m plus 1. 4 of m plus 1. 4 of m plus 1 is a 4 multiple. Therefore that will become again I to the power of 4, that equals to 1. So every number is of the form either 4m or 4m plus 1 or 4m plus 2 or 4m plus 3. Any number, if you see, they are of the form either 4 multiple or gives a remainder 1 or gives a remainder 2 or gives a remainder 3. So after dividing with 4, whatever the remainder you are getting, that will become as a power of I. So for example, if I take something number 2005, so 2005, if you divide with 4, this 2005, you will get the remainder 1. So therefore I to the power of 2005 will be equals to I to the power of 1 only, that is equals to I. So in this way you can calculate the powers of I. Whenever the exponent is very large, you divide with 4, whatever the remainder you are getting, that remainder will come as a power of I. So here 2005, if you divide with 4, the remainder is 1. So therefore I power 1, that equals to I. Now here we discuss one more important property of I. So whenever we have the highest power of I, how to calculate, just now we discussed. Now here one important property of the exponents of I is the sum of 4 consecutive powers of I is equals to 0 always. Sum of 4 consecutive powers of I is always 0. Sum of 4 consecutive, should be important, 4, they should be consecutive. So for example, I to the power of 2 plus I to the power of 3 plus I to the power of 4 plus I to the power of 5. So 2, 3, 4, 5, they are 4 consecutive numbers. So taking the powers of I power 2 plus I power 3 plus I power 4 plus I power 5 equals to 0 always. Why? I square we know minus 1, I cube we know minus I power 4 we know plus 1, I power 5 again, removing 4, I you will get. So therefore I will be the result of I power 5. Now plus I minus I get cancelled, plus 1 minus 1 get cancelled. So therefore that will become now 0. So in general, if you take for example an integer, 4 consecutive powers of I, considering that numbers are integers. So for example, one more I'll take. If I say n is an integer, n belongs to Z. If I say I to the power of n, the next consecutive integer is I to the power of n plus 1 plus I to the power of n plus 2 plus I to the power of n plus 3, that equals to 0, obviously. Because of n plus 1, n plus 2, n plus 3. They are 4 consecutive integers. So therefore the sum of 4 consecutive powers of I is what? Is equals to 0. Now, if I take one problem, calculate I plus I square plus I cube plus I power 4 up to I to the power of 2070. This is I want to calculate. What is the value of I plus I square plus I cube plus I power 4 up to so on I to the power of 2017. So here we have 2017 terms. We have to calculate the sum. But in this, all the powers you can see, they are consecutive integers. So by taking 4 at a time, I power 1 plus I power 2 plus I power 3 plus I power 4. So taking 4 at a time, this gives corresponds to the sum 0. Now next 4 will corresponds to 0. Next 4 sum corresponds to 0. Like that, all 4 terms by taking in order, they will become 0. So how many terms left at the end by removing 4, 4, 4, 4? So what is this actually? This is 4, 5 the 20, 4 for the 16. So remainder is 1. So the left out term is at the end I power 1. That equals to I. So this is the way of finding the sum of consecutive powers of I. Whenever they are consecutive, you can utilize this rule. You can utilize this rule. Sum of 4 consecutive powers of I is 0 provided they are integers. Right?